Hello everyone, my name is Dikshita Perikite and in this video I'm going to discuss about a research paper overview on the topic of the Astor tree, an efficient and robust access method for the points in rectangles plus sync presentation. This is the outline of our presentation, and in this video I'm going to the outline of this presentation gives the problem addressed, like was the problem addressed, like was actually the problem is, the significance and relevance of the problem, and difficulty of solving. There is some difficulty of solving the problem, and in this video I'm going to discuss what the difficulties that I have faced and the previous works in related literature, and what are the previous works that are there, and the literature too, and the algorithms, approaches, and ideas that are proposed, the conclusion, and what are future works, and the references which I have followed for doing this presentation. These are the problems addressed. The problem discusses the inefficiencies in the original R-3 data structure, especially with regards to how inefficient node splitting. The node splitting is something like it's very difficult. So this is the problem. And the part 3 architectures cause to performance flaws with specific data distributions and query patterns. With the data distributions also there is some problem. The study does indeed explicitly describe the problem statements pertaining to the inefficiency in the original R-3. Now, this case study, like this research paper, tells us the what are the inefficiencies that are in the R-3 to describe the problem statement. By stressing the impact of the inefficiencies on the performance, query performance, and the necessity of resolving these issues for increased efficiency in spatial data structures and databases and their applications, the author successfully draws the attention to crucial issues. The author mainly discussed about the issues that we are facing in this paper. Coming to the next slide, it's about the significance and relevance of the problem. What is the significance and what is the relevant solutions or the problem that we have identified? While the problem of the spatial indexing inefficiencies have been identified previously, in the previous, in the past work, already the spatial indexing is already identified. The the Astar tree proposed in this paper introduces it introduces a new technique where the novel enhancement to address these issues more effectively means the problem issues will be clearly stated in this paper. The problem is significant. It is very significant because efficient spatial indexing is crucial for the various real-world applications such as the geographic information systems, which is nothing but the GIS, and the database systems and spatial data mining. And then practical applications include location-based services. There are some practical applications like in the real which the problems that exist in the real world, which includes the location-based services, urban planning, planning of the urbanization, logistics, and geographic data analysis, where efficient query performance is essential for timely decision making and also the user satisfaction. In the next slide, we are going to discuss about the difficulty that I have faced in solving this problem. Problem is already identified and that is discussed in the previous one, and in this slide I'm going to discuss about the problems that I have faced when solving the problems. For everything we will face some problem in solving equation or any problem. The problem can be computationally complex. It is not simple. It is complex because of its dynamic nature of the spatial data and the requirements for the efficiently maintain balanced tree structures. The search space can be large. You all know about the search space, right? Yeah. Particularly for the high dimensional spatial data, necessity sophisticated algorithm for the efficient indexing. There are also the trade-off between the query performance, tree balance, and insertion or deletion of the efficiency can make the problem difficult to solve. These are the difficulties that I faced in solving this problem. In the next slide, I'm going to discuss about the previous work and the related literature. And the R-tree and its variations, along with the other spatial indexing structures, were among the earlier work on the spatial indexing. Already there is the spatial indexing technique, but including the spatial indexing technique, we are also concentrating on the R-tree, like R-star tree. By incorporating the major enhancements to overcome the shortcoming of the earlier techniques, the R-tree nevertheless builds upon earlier spatial indexing system. That is what I told just now. Node overlapping of the nodes, ineffective node splitting, and query performance degradation or among the assumptions and limitations of the above discussed the limitations and assumptions that we take in this paper, like the node overlap, inefficient node splitting, and query performance. These are the assumptions and limitations that we had discussed. And coming to the next slide, I'm going to discuss about the proposed approaches, algorithms, and ideas. Like what are the approaches that I followed, and what are the algorithms, and what is the main idea, like that. Yeah, as an improvement, like already there is the R-tree where the spatial indexing is there. The study suggests they suggest that the tree data structure, proposing the unique strategies for the node splitting and optimization techniques to boost the performance. Like in order to increase the efficiency or the performance level, we just follow the unique strategies for the node splitting and also for the optimization. This is the proposed approach. And the analytical and experimental assessment, in that one, we will compare with the original R-star tree and other spatial indexing techniques which are at the part of the experimental evaluation. The evaluation process makes use of the metrics like including the tree balance, insertion, deletion, efficiency, and speed. The speed is nothing but the query response speed, in the speed in which the query will run. And testing the statistical hypothesis can be used to confirm the importance of the finding, which is nothing but we're going to using the statistical analysis, like that it shows. And, and now we are going to discuss about the conclusion and the future work. I hope you all understand what 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 actually it means. And let me conclude it. The With the help of the R-star tree, the efficiency of the database system is increased, and the performance of the query becomes more easy, like the speed increases by addressing the major inefficiencies in spatial indexing. Its innovative improvements leads to advances in the spatial database administration and practical applications. This also used in the practical applications too. And coming to the future work, the R-star tree while doing with the R-star tree, we follow some algorithm, right? That can be optimized, and so that the efficiency will be increased more than this, and the scalability test for the huge spatial datasets and investigation of the potential applications in cutting edge domains like the machine learning and spatial data analysis are some possible avenues for the future research. Like we can use the machine learning and deep learning things for the performance of the queries in the database systems. That is what it all. And these are the references that I followed. The design implementation of the body tree from the Computer Science Technical Report, the University of Berlin, and then the grid file and adaptable symmetric multi-key file structure, ACM DRAM on the database systems, and at last I followed the art of the computer programming from the edition of the Wellesley published one. These are the references. If you have any doubts regarding anything what we had discussed about the aster tree, you can do comment in the comment section. Thank you for your patience. Thank you so much.